The last non-zero remainder is the highest common factor, that is called as the greatest common divisor of A and B. LCM into HCF is always equal to A into B. Now if you want LCM alone, LCM is equal to A into B divided by HCF of that number, or HCF is equal to A into B divided by LCM. So find out the LCM for the numerator and find out the HCF for the denominator. Hello dear students, welcome to this session of Basic Maths class. I am Mr. Niranjan, Faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed how to find the HCF, that is the greatest common divisor, GCD of numbers using factorization method, right? Now in this session, I am going to take how to find the GCD, greatest common divisor, using division method. That is called a division algorithm, right? Let us discuss how to find the GCD, the greatest common divisor of two integers. GCD, greatest common divisor of two numbers A and B by the method of a division method. That is called a division method to find the GCD. It's also called as Euclid algorithm method. Now here we are going to study Euclid's algorithm. Now to find the GCD of two numbers, let us consider any two integers. Let A and B are any two integers. Now without loss of generality, we can assume that B is greater than A which is greater than 0. B is greater than A which is greater than 0. Now on dividing B by A, suppose if you divide by A, let Q be the quotient and R1 be the remainder. If R1 is equal to 0, then A divides B. That is the HCF of A. If R1 is equal to 0, if the remainder is 0, then A divides B, then HCF of the given value is A itself is the highest common factor. So on dividing B, if you divide B by A, let Q is the quotient and R1 be the remainder. If R1 is equal to 0, then A divides B, thus HCF of A. So that is B by A. Then this is the quotient, R1 is the remainder. If this remainder, R is a remainder, if this is equal to 0, if R1 is equal to 0, then A divides B, thus HCF of these two numbers is A is the HCF, okay. Now that means if R1 is not equal to 0, divide A, divide this A by the remainder. We have to divide this A by R1 again. So then you are going to get the quotient as Q2 and R2 as remainder. If R2 is equal to 0, then R1 is the HCF. If R2 is not equal to 0, we have to proceed the procedure as usual. Now suppose if R1 is equal to 0, divide A by R1 and let Q2 be the quotient and R2 be the remainder. If R2 is equal to 0, then R1 is the HCF of A and B. Suppose if R2 is not equal to 0, then divide this R1 by R2 and the process is repeated. So that is, if R2 is not equal to 0, divide R1 by R2 and get the quotient Q3 and the remainder is R3. If R3 is equal to 0, then HCF is R2 itself is the highest common factor. Suppose if R3 is equal to 0, continue this process of dividing each divisors by the remainder until the remainder becomes 0. So we have to continue this process of dividing by the remainder until the remainder becomes 0. The last non-zero remainder is the highest common factor, that is called as the greatest common divisor of A and B. The last non-zero divisor, the last non-zero remainder, the last non-zero remainder is highest common factor of A and B. This process of finding the highest common factor or GCD of a number is called as Euclid algorithm. This is called an Euclid algorithm. So in general, suppose if you divide B by A, you are going to get Q1 as the quotient, R1 as the remainder, right? If R1 is not equal to 0, if remainder is not equal to 0, then divide this A by R1, you will get Q2 as the quotient and R2 as the remainder. If this R2 is equal to 0, then R1 is the GCD or HCF. If R2 is not equal to 0, If R2 is not equal to 0, again divide this R1 from this R2 and you will get Q3 as the quotient and R3 as the remainder. If R3 is equal to 0, then QR2 is the greatest common divisor. Suppose if R3 is not equal to 0, then divide again R2 by R3. This process is repeated until you will get the non-zero remainder. So the last non-zero remainder is the highest common factor of A and B, or the greatest common divisor of A and B. This process of finding the GCD of a number, GCD of any two numbers, is called the Euclid's algorithm method. This is called as Euclid algorithm. Very important concept. Now, let us take a small example on this. Find the highest common factor of 55 and 210. So, here A is 55, B is equal to 210, A is less than B. Let us divide 210 by 55. So, 55 3s are 165. What is the remainder? 10 minus 5 is 5. Again, this is 10 minus 5 is 5. Again, 10 minus 6 is 4. 45 is the remainder. Now, R is not equal to 0. Remainder is not equal to 0. Now, divide by 45. So, divide this 55 by 45. 45 ones are 45. So, 45, 5 minus 5, 0. This is equal to 10. Here, remainder is not equal to 0. Again, divide this 45 by 10. From 10, we are going to divide 45. How many times? 10 4s are 40. What is the remainder? Remainder is 5. This is also not equal to 0. So, again divide 10 by 5. From 5, we are going to divide this 10. 5 2s are 10, 0 is the remainder. So, the non-zero remainder is 5. So, this is the non-zero remainder. Non-zero remainder. Non-zero remainder. So, therefore, the greatest common divisor GCD is equal to 5, or this is also called as the highest common factor. HCF is equal to 5. So, 5 is the greatest common factor, or GCD is equal to 5. This is how we are going to find. This method is called a division method, that is by Euclid's algorithm method, to find the HCF or a GCD of a number. Very simple method. Just go on dividing by the remainder until you will get the 0. The non-zero remainder is called the GCD. The last non-zero remainder is the GCD. That's it. So, how to represent this symbolically? The GCD is denoted as 55, 210 is equal to 5. The GCD of 55 and 210 is 5. Now, let us come to the next problem. Find the HCF of the following numbers by division method. So, 104 and 130. Okay. Let us take, what is A here? A is equal to 104 and B is equal to 130. Let us divide B by A. 104, divide this 130 by 104. So, 104 into 1 is 104. So, 130 minus 104 is 26. Now, divide with this 26. This number, divide 104 with this 26. So, 26 into 3 or 26 4s are 26 into 4 is 104. The remainder is 0. So, therefore, the non-zero remainder is 26. So, therefore, the GCD, highest common factor, is equal to 26. That is 104, 130. The highest common factor HCF is equal to 26. That's it. Now, let us come to the next problem. Find the HCF of the following number by division method. So, here 3 numbers are given, 45, 90 and 180. Just find out the HCF of first these 2 numbers. HCF of 45 and 90. Now, 45 2s are 90. So, the remainder is 0. So, therefore, HCF of 45 and 90 is 45. The non-zero, since the remainder is 0, therefore, A itself is the HCF of 45 and 90 is equal to 45. Now, find out the HCF of 45 and 180. Now, let us divide this 180 by 45. So, how many times? 45 4s are 180. Remainder is 0. So, here again HCF of 45 and 180 is 45. So, here HCF is 45 and HCF is 45. Therefore, highest common factor of HCF of 45, 90, 180 is equal to 45. 45 is the highest common factor for these three numbers. That's it. Okay. First find out the HCF of 45 and 90, and again it's this HCF and 180 that will give the highest common factor for the three numbers. Okay. Now let us come to the next problem. Find the HCF of the following numbers. Again three numbers are given by division method: 12, 15 and 24. Okay. Now let us find out the HCF of 12 and 24. Easy to find. So HCF of, let us find out the HCF of 12 and 24. So 12 and 24. 12 2s are 24, 0 is a remainder. So therefore the HCF of 12 and 24 is 12. Now find out the HCF of 12 and 15. Now HCF of 12 and 15. HCF of 12 and 15. So that is, divide this 15 by 12. 12 ones are 12, 3 is the remainder. Again divide this 12 by 3. 3 4s are 12, 0 is the remainder. So therefore this is the HCF. The non-zero remainder is 3. So therefore the HCF of 12 and 15 is 3. So in conclusion, therefore the HCF of 12, 15 and 23 is 3. So therefore the HCF of 12, 15, 24 is equal to 3. That's all. The HCF of 12, 15 and 23 is 3. That's it. Okay. Hope you followed how to find the HCF of three numbers. Now let us come to the next problem. Now what is the problem given? Find the greatest integer which divides 42, 52 and 86, leaving a remainder of 6, 4 and 2 respectively. So find the greatest integer. We have to find a greatest integer, GCD, common factor, greatest common divisor, which divides this 42, 52 and 86. It will divide three numbers. After division, it will give a remainder of 6, 4 and 2 respectively. Okay. Since what are the reminders? The reminders are 6, 4 and 2, 6, 4, 2. Subtract these reminders from the given number. So find the HCF of, first we need to find the HCF of the numbers, this 42 minus 6, again 52 minus 4 and 86 minus 2. So that is nothing but 6, 4, 2 are the remainder. So therefore subtract 6, 4, 2 from these numbers. 42 minus 6, again 52 minus 4 and 86 minus 2. 42 minus 6 is 36. Again 52 minus 4. 52 minus 4 is 48. Again 86 minus 2 is 84. So find out the HCF of 36, 48 and 84. Now find out the HCF of 36, 48 and 84. Write down the factors. Just by factorization method we can find out the factors for 36. So this is 3 1s are, 3 2s are, again 3 4s are, again 2 2s are. So 36 can be written as 2 square into 3 square. 3 square is 9, 2 square is 4, 9 4s are 36. Similarly 48 can be written as, simplify 48 can be written as, so this is 2 2s are, 2 4s are, again 2 1s are, 2 2s are, again 2 6s are, again 2 3s are. So 48 can also be written as 1 2 3 4, 2 to the power of 4 into 3 to the power of 1. And last one 84 can be written as, again 2 4s are, 2 2s are, 2 2s are, 2 1s are, again 3 7s are. So therefore 84 can be written as 2 square into 3 to the power of 1 into 7 to the power of 1. These are the factors, right? Now find out the highest common factor. So what are the common factors here? The common factors here, 2 square and 2 square. So we have 2 square here, 2 square is also 2 square. So the common factor is 2 square into, next 3. See, 3 is here, 3 is also here and 3 is also here. 3 square, 3 to the power of 1, 3 to the power of 1, 3 to the power of 1. So this is nothing but 7 is there, 7 is not there. So 2 square is 4 into 3, 4 3s are 12. So therefore the highest common factor for the two numbers is 12. That's it. Okay. Just find out the HCF. So therefore the greatest integer is nothing but 12. So 12 is the greatest integer on dividing these numbers, it will give the remainder 6, 4 and 2. See, if you divide 42 by 12, you will get 6 as the remainder. 52 by 12, you will get 4 as the remainder. And 86 by 12, you will get 2 as the remainder. That's it. Okay. Now, let us come to the next problem. Now, next one is the relation between the LCM and HCF. Very important concept. The relationship between the LCM and the HCF, least common multiplier and the highest common factor. Suppose if A and B are any two numbers, then the product of their LCM and HCF is always equal to product of two numbers. Suppose if A and B are any two numbers, then the LCM and HCF of these two numbers is equal to product of LCM into HCF is equal to A into B. That is, LCM into HCF is always equal to A into B. Now, if you want LCM alone, LCM is equal to A into B divided by HCF of that number, or HCF is equal to A into B divided by LCM. So, therefore, very important formula, LCM into HCF is always equal to A into B. A into B. This is the formula. This is the relation between LCM, HCF of two numbers A and B. Now, based on this, let us take few problems. Now, if the HCF of two numbers is 42, given what is given, HCF is equal to 42 and their product A into B, product is equal to 52920, find the LCM. LCM is equal to question mark. So, here what is given, we know the relation LCM into HCF is always equal to A into B. The product is given. What is HCF is given? HCF is 42 into LCM is equal to the product. Product is 52,920. So, therefore, only the LCM is equal to 52,920 divided by 42. Divide 52,920 divided by 42. The answer you are going to get itself as the LCM. Okay. So, this is equal to 1,260. So, therefore, the LCM is equal to 1,260. If you want to verify verification, just multiply LCM into HCF is equal to A into B. What is LCM? LCM is 1260 into HCF is equal to 42. If you multiply this 1260 into 42, so definitely that's equal to 52,920. That's it. The given answer. Okay. Hope you followed. Right. Now, let us come to the next problem. The HCF of two numbers is 16 and their LCM is 160. If one number is 64 and find the other number. This is also very important for 3 marks. 3 marks question. Very important. What is given? Given that. So, HCF of two numbers. HCF is equal to 16 and their LCM, least common multiplier, LCM is equal to 160. If one of the number A is equal to 64 and B is the question mark, find out the other number. Very simple and important problem. So, you know the relation HCF into LCM is equal to A into B. Okay, what is HCF? HCF is 16, LCM is 160 is equal to A is 64 into B. So, just B can be written as 16 into 160 divided by 64, right. So, what is this equal to? 16 4s are 64. So, B is equal to 160 divided by 16. 4 4s are 16. That's equal to 40. So, therefore, the other number B is equal to 40. So, here HCF is 16, LCM is equal to 160 and A is equal to 64, B is equal to HCF into LCM divided by A will give the value of B, that is equal to 40. That's it. Okay, hope you follow. Right. Now, let us come to the next concept. So, to find out the LCM of a fraction, how to find the LCM of a fractional numbers? To find the LCM of numbers like A by B, C by D and E by F, if they are in proper fractions. If A by B, C by D, E by F are proper fraction, then the LCM of these fractions is given by LCM of the numerator A into C. Suppose if A by B, then C by D, then E by F are in proper fraction, then the LCM of this is given by the LCM of these numbers is nothing but the LCM of the numerator A into C into E divided by the HCF of the denominator B into F into D. Now first, to find out the LCM for a proper fraction of the form A by B, C by D and E by F, just find out the LCM for the numerator and find out the HCF for the denominator. So if you divide LCM of numerator by HCF of denominator, you will get the LCM for the given fractions. Okay. Now let us take an example based on this. Find the LCM of 1 by 3, 5 by 6 and 2 by 9. So what is given here? The factors are 1 by 3, 5 by 6 and 2 by 9. So these are proper fraction. First find out the LCM of numerator 1, 5 and 2. Then HCF of the denominator. HCF of denominator is 3, 6, 9. Okay. The LCM of numerator. LCM of 1, 5, 2. So that is, so 1, this is from 2, this is as it is. 1, 5, 2, again from 2, again from 5. So therefore 1 into 2 into 5, that is nothing but 10 is the LCM. For the numerator, the LCM is 10. HCF, find out the highest common factor for this. So the common factor, HCF, the common factor for this is 3 into 1. For 6, the common factor is 2 into 3. Again for this, 3 into 3. The common factor is 3 is the common factor. So highest common factor is 3. The highest common factor, 3 to the power of 1. So that is 3 is the highest common factor. So HCF is equal to 3. HCF of 3, 6. So what is the formula? Therefore, the LCM of this, the LCM of the given number, LCM is equal to, LCM of the given number is equal to LCM of numerator. LCM of numerator is 10 and divided by HCF of the denominator is 3. 10 by 3 is the required answer. So therefore, the LCM of this is equal to 10 divided by 3. That's it. Okay. Now let us take a similar type problem. Find the LCM of 6 by 7, 5 by 14 and 8 by 21. So first find out the LCM for the numerator. LCM of 6, then 5 and 8. So 6, 5 and 8 LCM. Write down 6, 5 and 8. So let us start with 2. 2 3s are, 2 5s are, 2 4s are. Again from 2, this is 3, 5 as it is, 2 2s are. Again you can start with 2, 3, 5, 1 as it is. Again from 3, 3 1s are, 5, 1. Again from 5, 1, 1, 1. So therefore this can be written as 2 to the power of 1, 2, 3. 2 cube into 3 into 5. The LCM of this is equal to, multiply this, that's it. 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 into 5. That's equal to 120. 120 is the LCM in the numerator. Okay. And find out the HCF. So the HCF for the denominator. What are the denominator terms? 7, 14, 21. So the factors are 7 can be written as 7 into 1. 7 to the power of 1. 14 can be written as 2 into 7. So that is nothing but 2 to the power of 1 into 7 to the power of 1. 21 can be written as 3 into 7, 3 is 21. So 3 power 1 into 7 power 1. Now what is the common factor here? The common factor is 7. Highest common factor is 7 to the power of 1 is equal to 7. So therefore HCF is equal to 7. So the LCM of these two numbers, 6 by 7, 5 by 14 and 8 by 21 is LCM. LCM is 120 divided by the HCF, that's equal to 7. So the required answer is equal to 120 divided by 7 is the required answer. That's it. Hope you followed. Very simple type. Find out the LCM in the numerator and HCF in the denominator. LCM of numerator divided by HCF of denominator will give the LCM for the given fractional values. Now let us come to the next problem. So to find the HCF of fraction. So how to find the highest common factor? So we have just LCM now, HCF of the fraction. So for a proper fraction, how to find the highest common factors? HCF of numerator ACE divided by LCM of the denominator will give the highest common factor, right? Listen to me. Let me explain once again. The highest common factor of the fractions is nothing but to find the highest common factor of the fraction. What is the formula we are going to use is find out the HCF of a numerator divided by the LCM of the denominator terms. So that is nothing but HCF of the numerator terms A, C and E, A, C and E divided by the least common multiplier of the denominator B, D and F, B, D and F. So therefore this will give the highest common factor. So the highest common factor HCF of numerator by denominator is equal to HCF of numerator divided by the HCF of the denominator term. Let us take one small example. Find the HCF. So here the numerator terms. What are the numerator terms? What is to find HCF of? Find out the HCF of 8, then 32 and 16. And similarly the LCM of the denominator, LCM of 9, 81 and 27. So this is to be determined first. Now find out the factors for 8. 8 can be written as 2 cube, 2 cube, 2 to the 4, 4 to the 8. 32, 32 can be written as, how to simplify this? 2 1s are, 2 6s are, again 2 8s are, this is 2 4s are, again 2 2s are, 1 2 3 4 5, 2 to the power of 5, 2 to the 4, 4 to the 8, 8 to 16, 16 to the 32. And 16, 16 can be written as 2 into 8, again 2 into 4, that is 2 into 2, that is nothing but 2 to the power of 4. 16 can be written as 2 to the power of 4. So 2 to the 4, 4 to the 8 to the 16. What is the common factor in this? The common factor is 2 cube. 2 cube is the common factor, right? The highest common factor is 2 cube. Therefore HCF is equal to 2 cube means 8. HCF of this is 8. HCF of 8, 32 and 16 is 8. The highest common factor is 2 cube, 2 to the 4, 4 to the 8. So now let us come to the LCM. Find out the LCM of this. LCM of 9, 81 and 27. So let us start with 3. 3 3s are. Then this is nothing but 81 can be written as 3 2s are 6, 3 2s are, 3 7s are, 27 3s are, again 3 9s are, again from 3. 3 1s are, 3 9s are, 3 3s are, again from 3. This is same 3 3s are, 3 1s are. So therefore this is nothing but 3 3s are 9, 27 3s are 81. So LCM is equal to 81. So therefore the highest common factor for this is HCF of numerator, HCF of 8, 3, 2, 16 divided by LCM of denominator 9, 81, 27. That's equal to HCF. What we got is 8 divided by LCM is 81. 8 by 81 is the simplified answer. So the highest common factor for 8 by 9, 32 by 81, 16 by 27 is 8 by 81 is the required answer. Hope you followed how to find the LCM and HCF of fractional values. These are few concepts on Euclid algorithm and also finding the HCF and LCM of a fractional value. So that's all regarding this session. Let us meet with the different concept in the next session. Thank you very much.